Okay, 8.3 is logarithmic functions. What are logarithmic functions? You've studied this before in math classes before. You should know that exponential functions and logarithmic functions are related. We talked about that, I believe, too, right? A few sections ago. We talked about how to rewrite an exponential function, like, for example, y equals 2 to the power of x, right? Which would be this graph right here. Something like that, before we talked about e. And we talked about how to write this as a logarithmic function, right? Who remembers? Log of, there's going to be a base, there's going to be a number here, and there's going to be a number over here. Okay, so which goes where? Because we can interchange the forms, right? So what goes here in the base position? 2, actually, because 2 is the base for this exponent. Okay, so what goes here? Y, and what goes here? X. Okay, so really, this is where y is isolated. If you are given a log function and you're asked to solve for y, that's how you do it. You go from the log version to the exponential expression, the exponential version of it. Okay, so if we have, and again, this is just a bit of a refresher. If we have log of 64 base 8, what does that equal? 2, right? Because 8 to the power of 2 is 64. Okay, good. So that is 8 squared equals 64. So what if I didn't know this, or what if this was the variable, and that is now y? Well, what did I just erase? I just erased the 64. So do you see, this is how you kind of solve for y here? If you have a log function, you solve for y by rewriting it in an exponential, as an exponential function. Now, if I've got x, I've solved for x, I need to solve for y, really, okay, this log right here and the exponential form, okay, right here, is they're inverses of each other. So a logarithm is the inverse of an exponential. And so what does that do for graphing? Well, I'm just going to graph here for you. Let's see, I'll get rid of it. Well, actually, I'll leave that one up there. Okay, so y equals 2 to the power of x. The inverse, or the related log function, right, would be what? How am I going to write that? Well, I guess we could do, let's do 1 divided by 2 to the power of x. Let's see what that gives us. 2 to the power of x. Now that's a reciprocal function, so let's see what that looks like. Okay. Yes, it's like 1/2. Good. So is that an inverse? Well, an inverse and reciprocal aren't the same. So let's say, what we do? 2 to the power of x. And y equals 1 over 2 to the x. You're right, is the same as 1/2 to the power of x. These are reciprocals. Okay? Reciprocals. Okay, so let's do, and I don't know if we can do it actually on this calculator, to tell you the truth. So we may have to just do it by hand. So let's see, we want to also graph y equals, or, well, we're going to do log of x base 2. Okay, so that's the inverse. So we've got 0 and 1. What about x equals 1? What is the y value when x equals 1? So that is 2 to the power of what? Gives us what? 2 to the power of what gives us 1? What is that? So x is 1. we've got that there. 2 to the power of what gives us 1? No, 2 to the power of half, that's root 2. Yes, 0. 2 to the power of 0 in here gives us 1. So we've got 1, 0 is our point. So if we're doing a table of values here, 1 goes with 0. Okay. Let's change it up here to 2. If this is 2, what's the exponent? Right. Okay. So this is, remember, this is x here. This is y. So now we've got 2 to 1. Okay, what's another easy one we can check? What number would I put here that's pretty... Yeah, good, 4. And this is 2. Okay, so 1, 2, 3, 4, 1, 2. Okay, so this is what we got so far, and we could connect these points. And I'll just do that for you. What about between 0 and 1? So 2 to the power of what gives us 1 half, let's say. If x is 1 half, what is y? Minus 1. Very good. You guys see that? 2 to the negative 1 gives us 1 half. And what about 1 quarter? 2 to the negative 2. Yeah, good. So we've got, now this is going to get a little... So this is the graph of our logarithm function right here with base 2. Do you guys remember in pre-calculus 30 when we talked about inverse functions? They are a reflection of what? Yeah, a reflection in y equals x. So if this is y equals x, you see how these are a perfect reflection? Or, I mean, maybe not with my drawing, but they're reflections. So on page 369, you see that in your textbook. So that's what the graphs look like. We talked about, probably more than we should have here already, about logarithms and exponential functions. Maybe you didn't need all this teaching. But here's what the graphs look like. They are inverses of each other, so they are a reflection about this y equals x line. Okay, which is the exponential function that we just learned about that is really, really handy for us as students of calculus? Y equals e to the power of x, right? Yes. That's a really nice exponential function for us to work with. And why is that? Remember? Yes, the derivative is itself. That's exactly right. So if you have y to e to the x, the derivative equals itself. Okay, very good. Now, there should be a logarithm, okay, that is the reciprocal of this special exponential function. And there is. So really, it's y equals the logarithm of x with base e. And that's what this graph is right here. Okay. That's what this would be, the inverse of y equals e to the power of x. And it has a special name. So log of x base e is the natural logarithm of x. So do you remember I talked about common logarithms before? I mentioned that last couple classes ago. No? Yes? What's the base on the common logarithm? 10. Yes. So log of x base 10 is the common logarithm, and the natural logarithm is log base e. So guess what? There's a special notation for log base e, and that comes from the Latin form of natural logarithm, logarithmus naturalis, something like that. And it's ln x, the natural logarithm of x. So this right here equals this right here. So that's something that you'll, again, notation, that you'll need to recognize. So following that, if we're talking about the natural logarithm, so ln of x, if that equals y, then we also have e to the power of y equals x, right? This ln is log of base e. So we could rewrite it like that. So that's important for you to know, that that's just flipping from logarithmic to exponential. Another thing that's going to come in handy is if you have the natural logarithm of e to the x, that equals x. Because it's like saying this, log base e of e to the x equals x. It's like saying e to what power, is going to give us e to this power. So e to the what gives us e to the what? Well, e to the x will give us e to the x. Okay? So it's basically, Also, just one more that you want to use is natural logarithm of e equals 1. That's also important to recognize, because this is like saying the log of e to the 1 base e equals what? Well, e to what power gives you e to the 1? E to the 1. Alright, so those are a few things that you need to know, and well, I guess I said that was one more, but I do want to tell you about this one too. The natural logarithm of 1 equals what? I'll let you tell me that one. What goes there? Try not to look in your books. So this is the logarithm base e, right, of 1. So e to what power gives you 1? E to what? Sorry? 0. True. Yep. Very good. Okay. Okay, so let's do this example here, and like I say, this isn't really a lot of calculus here yet. We're not doing derivatives yet of this stuff, but I just want to reinforce, I guess, some relationships here. So if you had something like this and you were to solve it, it looks really scary because there's the x right there. It's in the exponential position. So you're thinking, okay, I'm going to need to use some kind of logarithm to get it out of there. And I have this e base, so what do I do? Okay, in order to solve this, you would take the natural logarithm of both sides. And taking the logarithm of both sides is something you can do in an equation, no problem. Okay. All right. So how can we rewrite this? Well, what did we say here? Natural logarithm of e to the power of something equals what? What did we just write that down? Natural logarithm of e to the power of something equals what? Yeah. So I have natural logarithm of e to the power of something. Natural logarithm of e to the power of something. That is the same as just writing whatever that exponent is. It's the exact same. So what this is saying is that you have the natural logarithm with of a power that is base e. It's like this and this cancel each other out. And so really you could rewrite this as 3 minus 2x. That's how you kind of bring that out of the denominator. Equals natural logarithm of 4. All right, so now x is out of the exponential position. You can just solve for it like you normally would. So it would be negative 2x equals. And ln of 4, and oh, notice I'm saying ln of 4. That's kind of slang for natural logarithm. You can say ln of 4. That's what us geeky math people do. So ln of 4 equals negative 2x minus 3 divided by negative 2. So we get ln of 4 minus 3 over 2. And that's what x equals. And you could, if you want, work that out to a decimal, but that's what x equals. That's how you solve for x there. Is there a ln button? Yeah. Good question. Good question. You see E somewhere on your calculator? I'm not sure if I have. This is not maybe easy to do on my calculator. Where's I have E here anywhere? I don't know. Oh, yeah, there it is. Oh, sorry, here it is. Yeah, E to the x and ln, right here, sorry. Lonnie? No, not Lonnie. Just ln. Yeah. All right. Dividing by -2, thank you. For these questions, no, you don't have to simplify it more. No, if it asks you for a decimal, then you do. Just plug it into your calculator, which you do have a ln button on your calculator. Go back to there, right here. So natural logarithm of 4 equals 1.3862. So, yes, and thank you for the negative there. All right. Okay, because that was really short, and because we should do some actual calculus today, I'm going to tell you what the derivative of these functions is. So this is technically 8.4. 8.3 was really short. Derivatives of logs. So what is the derivative with respect to x of the natural logarithm of x? Well, let's take a look at this. If we start off with y equals ln of x, and I take the and I look at this and I say I can rewrite that a certain way, e to the power of y equals x, right? And I take the derivative of this right here. If I take now the derivative of this, d over dx, what's the derivative of e to the y? E to the y times what? Yes, because it's with respect to x, times y prime, or I guess I'm using Leibniz, dx, dy dx. Okay, so that's chain rule, good. And with respect to x, what's the derivative of x? 1. Okay? And so the derivative of y with respect to x equals 1 over e to the y. And what did we say e to the y was from the original question? It's x. So dy over dx equals 1 over x. And so that is the derivative of ln of x with respect to x is 1 over x. So are you asking how I got from here to here? Yeah, from the original question here, when I rearranged this right here into this, if you end up with 1 over e to the y, what is e to the y in this question? It actually equals x, so you could rewrite it as 1 over x. Okay, so that's pretty nice. Just like e to the y, like e to the x, its derivative is itself. Ln of x has a pretty simple derivative too, just 1 over x. And if this was ln of u, anything other than x, right? And you were doing it with respect to x there, it would be 1 over u times du dx. And basically it's just chain rule. That's just chain rule there. Okay, so I'm not sure if that... It's good to see this kind of notation. That is the chain rule, right? This is something other than x, so you do 1 over that thing and then multiply by the derivative of this with respect to x. So it's just chain rule. Alright? Shall I stop there? Yeah, I'll probably stop there. Probably stop there and let you guys do some practice on all this stuff here, okay? I won't do the derivative of exponentials, which is the last part of this section. So, all right, so just to review our lesson for today, we've talked about really 8.3 log functions and exponential functions. We graphed them and talked about the logarithm with base e is called the natural logarithm. Some important relationships that you're might want to remember. We learned how to solve for x with an e exponential function there. And we also took a look at what the derivatives of ln of x is, the derivative of ln of x, a little bit from 8.4.